Good morning students. Today we will discuss about D block elements, transition properties. What are transition properties? Yesterday we will discuss about introduction of D block elements. Now we will discuss about transition properties of D block elements. So what are transition properties? So D block elements which are having unpaired electrons in d orbital, unpaired electrons in d orbital, unpaired electrons in d orbitals, unpaired electrons in d orbital. They exhibit some different properties. These properties are called as transition properties. These properties are called as transition properties. What are the transition properties? What are the transition properties? For example, zinc. If you take zinc, Zn is 30 atomic number. So argon 3d10 4s2. So when you observe the zinc electronic configuration here, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So no unpaired electron. There is no unpaired electron. No unpaired electron. No unpaired electron. Therefore, it does not exhibit some properties. What are the properties I will explain? If you take chromium atomic number is 24. Or copper we take chromium. So chromium, argon, 3d5, 4s1. So here in d orbital 1, 2, 3, 4, 5. 5 unpaired electrons are there. Therefore, it is transition element. It is considered as transition element. It is considered as transition. It is not considered as transition element. Therefore, zinc, cadmium, mercury. Cadmium is also. Cadmium atomic number is 4d10 final, 4d10 5s2, outermost electronic configuration 4d10 5s2. There is no unpaired electron in cadmium, so they belongs to D block, but it does not exhibit different properties of transition properties. Therefore, cadmium and mercury is also mercury 5d10 6s2. This is also mercury is a D block element but not transition element. So this is about what are transition properties. What are transition properties? So transition properties means first one is variable oxidation states. So first one is variable oxidation states. Variable oxidation states. What is variable oxidation states? More than one oxidation state. More than one oxidation state. More than one oxidation state is called variable oxidation state. For example, so here iron, if you take iron exhibit Fe plus 2 and Fe plus 3. So manganese can exhibit Mn plus 2, Mn plus 4, Mn plus up to Mn plus 7, like that. More than one oxidation. This is called ferrous, and it is called ferric, like that. For example, zinc we take when you observe only one oxidation state, that is Zn plus 2 oxidation state. Therefore, here they exhibit more than one oxidation state. That is one of the transition property of the D block element. That is also one of the important transition properties of D block. They exhibit variable oxidation state. Variable oxidation states means more than one oxidation state is called as variable oxidation state. So iron, copper is a cuprous and cupric ions are we observe. Cuprous and cupric is also we are observed. So iron, ferrous and ferric. Ferric means Fe plus 3. Cuprous, cupric, like that. Cuprous, cupric. So more than one oxidation state, it is one of the transition property. After that, second transition property is color properties. So iron salts and cuprous salts, for example, FeCl3, and FeCl3 is in some little bit red color, and copper sulfate is blue color, but ZnSO4 is not color. So when they are dissolved in water, or water maybe they give Fe plus 3 ion, they give C plus 2 ion, Zn plus 2 ion. For example, aqueous copper sulfate solution is blue in color. It is colorless. So colorless and means this is also one of the property. Due to unpaired electron substances, those are having unpaired electrons, they exhibit color properties. Due to DD transition, some properties are related for this. So therefore, copper sulfate is exhibit blue in color, but zinc sulfate does not exhibit any color because that is one of the transition property. After that, we discuss about magnetic properties. They exhibit magnetic properties. So why you are comparing with always zinc? Means zinc is D block element. These two are transitional. These are also D block and transition. These two are D block and transition elements. But zinc is only D block element. That's why always we are comparing with the zinc with other elements. After that, we'll discuss about the magnetic properties. So what are magnetic properties? So magnetic properties are mainly divided into three types. So you know that one paramagnetic, ferromagnetic and diamagnetic. So magnetic, they also exhibit magnetic properties. So magnetic properties are mainly divided into three types. Paramagnetic, ferromagnetic, diamagnetic. Paramagnetic, ferromagnetic and diamagnetic. Para means the elements which are having less number of unpaired electrons. So weakly attraction by the magnetic field. Weakly attraction by the magnetic field. Ferromagnetic means strongly attraction by the magnetic field if it has more number of unpaired electrons. Diamagnetic repel. They are repelled by the magnetic field. Repelled by the magnetic field. So ferromagnetic, paramagnetic, diamagnetic means which having more number of unpaired electrons. If it has 5 unpaired electrons, it is ferromagnetic. if it is ferromagnetic. If it has one unpaired electron, then exhibit paramagnetic. Diamagnetic, zero unpaired electrons. They exhibit diamagnetic. Zn. Zinc is a example for the diamagnetic substance. There is no unpaired electrons in the zinc. Therefore, it exists as diamagnetic substance. ZnSO4 or whatever it may be the substance, they are diamagnetic in nature. So magnetic properties are mainly divided into three types: paramagnetic, ferromagnetic, diamagnetic. So paramagnetic means the substances which are weakly attracted by the magnetic field, they are called as paramagnetic substances. The substances which are having less number of unpaired electrons, they exist as paramagnetic substances. Less number of 1 or 2, like that. Ferromagnetic substances means the substances which are having more number of unpaired electrons, which are strongly attracted by the magnetic field. So strongly attraction means if they are having more number of unpaired electrons. Next one, diamagnetic substances. The substances which have no unpaired electrons, means they are repelled by the magnetic field. So by this is also one of the property to separate d block elements and transition elements from the d block elements. So therefore it is also one of the transition properties. After that we discuss about other properties, other transition properties. Fourth property, they act as catalyst. So what is catalyst? The substance which does not participate in chemical reaction but increase the rate of reaction. So this is also one of the transition property. Why d block elements acts as catalyst? Because they provide large surface area. So that's why they can act as catalyst. So catalytic property is also one of the transition property. For example, in Haber process, we are using iron. Finely divided iron is used as a catalyst to prepare ammonia. Finely divided iron is used as a catalyst. In hydrogenation of oils, nickel is used as a catalyst. These two are d block elements. Because in Haber process, N2 plus 3H2 gives rise to NH3. Ammonia product is formed. Here we are using iron. These are very smaller molecules. Ammonia is also smaller and this is also smaller because it provides large surface area. Iron provides. Thing is, they are react with each other like this. So they are combined on the surface of the iron. So what is the functioning of iron means? In this, so it is iron surface. In this, nitrogen and hydrogen react and form the ammonia. This is iron because it's large surface area. It can provide large surface area. That's why they are exhibit. They act as catalyst. D block elements. So it is also one of the important transition properties of d block elements. D block elements are acts as catalysts. Some examples already given. So vanadium pentoxide is used as a catalyst. V2O5. SO2 plus half O2 gives us SO3. In this vanadium is combination with oxygen, vanadium pentoxide. Vanadium belongs to D block group. Therefore, vanadium pentoxide is used as a catalyst. It is also one of the transition properties of D block elements. So why they are used as catalyst means because they provide large surface area. In this large surface area, these are reactants are reactant from the products. Therefore, it is also one of the important thing of the catalyst. After that, fifth property is formation of alloys. So what are alloys? Alloys means homogeneous mixture of two or more metals are called alloys. Formation of alloys. Combination of two or more metals. Copper, Zn. Next one, copper iron, copper manganese, and aluminium. So these are combined with each other to form the alloys. Alloys means the homogeneous mixture of two or more metals. So they improve the properties. For example, in aeroplane parts are in the manufacturing with the alloys only. Some properties. So therefore, this is also one of the important property of the D block elements. After that, next one, formation of coordination compounds. Formation of coordination or complex compounds. Formation of coordination compounds. Formation of coordination compounds. These are also called as complex compounds. So here, in this complex compounds, these are special type of compounds. Any K4FeCl6, for example, potassium K4FeCl6. It is a complex compound or coordination compound. In this complex compound, D block element acts as a central atom. So D block element is like this, and it is day2 bond. So these are formation of and form this is central atom. It acts as a central atom, and there is like this cyanide, 6 cyanide groups. So it acts as a cyanide and 4K plus ions. So this is complex compound. The structure is like this. Simple, I have given one structure. So in this, whatever it may be, in complex compounds or coordination compounds, D block elements are acts as central atom. They are in the center of that compound and surrounded by some substances. Whatever ligands and ions are surrounded by them. So whatever it may be, in the complex compounds, D block elements are acts as central atom for these compounds. So therefore, means D block elements are one special category is there for them, that is formation of coordination compounds by day2 bond. The coordinate bond is in between is there. This we are observed this one. So this is also one of the important property of the D block elements. So these properties are called transition properties. So many properties are there, but just this is a briefly I am explaining these properties.